Hi, my name is Teddy Wafula and I'm a software engineer. Today we are going to look at functions in Python. So we are going to look at how to define a function, how to call a function, how to use arguments in a function, and a simple example of recursion. And we will finish with a simple example also on binary search on a function. So a function is a piece of code that is reusable. It simplifies your code in such a way that you do not repeat yourself when writing a certain function or writing code to do a certain purpose. So that's the reason why we use functions. So at first we'll have to start by opening our favorite IDE or text editor. For my case, I'm using a text editor called PyCharm, and ensure that Python is installed on your machine. So for my case, I can go to the terminal and type Python. Ensure that Python is installed on my machine. So let's start off with the function definition. But first, I would like you to subscribe to my channel to get more updates, and click also on the notification icon so that you can get more of these tutorials from the basic level up to the advanced level. So we are going to start off with function definition. To define a function, you start with the def keyword, and then you enter the function name. Let's say I get a name. So when you write that function, you open parentheses and close the parentheses. Inside the parentheses, you enter what you call the arguments. They are not necessary if you are not going to use them, but it's good if you enter the arguments. So for my case, I'm going to use name as an argument. Then after that, you close the parentheses. After closing the parentheses, you enter the full colon. And then now, when you press enter inside the function, you have to indent for spaces. So PyCharm already comes with those autocomplete features. So just for demonstration purposes, let me go to the start and enter 4 spaces. 1, 2, 3, 4. So here, let's say you want to put comments on how your code works, or what function your code does. So you'll use docstring parameters if it's a long description. So here you say a function to get name. So when you do this, the comments are not printed when you print your function. They just guide you on your code for easy debugging purposes. So here, let's say you want now to output your name. You say print a name. And then you return you return nothing, because you're going to return nothing. You can return either name or return nothing. So return simply means what expression are you going to give back to the client. So for our case, we're not going to bring out any return. So when you come here, we're going to call our function and say get name. That's how we call our function. You enter the name, then the parentheses, you open parentheses, you close them, then you enter now the value of your name, then you click run. So there it is. Down here, you'll see there is test. The importance of the function is that it's reusable, so you can come here and write another name like John. So when you run this one, you'll see test, then John. So basically we have looked at how to define a function and how to call a function in the simplest way. So we are going to another advanced feature. We are going to look at how arguments or parameters are defined in a function. So first we have required arguments. Like for our case here, if you don't enter name, it will give you an error about positional arguments. So it will say you are missing one required positional argument, name. So you have to enter the name and say test name, so they don't have an error. So this is an example of a required argument. So another feature that we're going to look at in terms of arguments is the default argument. A default argument comes with an already predefined value. So for our case, let's say our name is you can say Peter, and then we call a function down here saying get name, then we don't enter anything. So when you run, you'll see the value Peter here. So this one shows that it's using our default value and it's not throwing an error. So whether you enter the value or not, it will still print the default value. So next we are going to look at keyword arguments. Keyword arguments means you have a key name like age, and then another one is called name, another one can be called email. So when you want to get your value, you have to specify that argument with the name that you defined in your function. For example, if you say def get details, then inside the details you have a positional argument, a name, then you have email, then you have age. Then when you want to run so let's say here docstring get details. So here you are going to print going to say age equals, then you say age, then you say print. You are going to print also name is name. I'm going to print email, and I'm going to return nothing. So when you come here and say get details, then you say let's say you start with, let's say, email equals test@test.com. Then you say age equals, let's say 23. Then you say name equals my name. So if you run this function, this is what you are going to get. Age equals 23, which is here. Name equals to that one. Then the email equals to this one. So you can notice that we are not in the calling of the function, we are not using a specific order. We are just calling randomly, identifying each value with its keyword. So here the name in our function comes first, but here you can put it anywhere. It can be last or second or first, irrespective. So that means that you can call or you can declare a function using keyword arguments, and you can get your data using keywords. So next we are going to look at other types of arguments called arbitrary arguments. Sometimes you might not know the number of arguments that you might expect in a function. So we use what we call arbitrary arguments. So I'm going to demonstrate that. So let's comment this and comment this. So you can say define a function to get arbitrary arguments. So in your arguments you start with an asterisk, then you say arbitrary argument. You can use any name, not necessarily what I've written there. Then inside your function, let's say put a comment and say using arbitrary arguments. So when you use arbitrary arguments, for you to get any values, now that you don't know what the user will enter, we are going to use a for loop. So you can say for I, or for data in arbitrary arguments, print the data. Then here you are going to return empty. So when you come and call your function of get arbitrary arguments, if you do not enter any value and click run, you're not going to get any data. So if you enter a value and say let's say test 1, you can enter test 2, also say example 3. So if you run this, you are going to see a list of data. So here you have test 2, then example 3. So that's the third way of defining or using arguments. We are also going to look at arbitrary keyword arguments. Remember up here we looked at keyword arguments. Here at get details, we have name, email, and age. So that's what we had. But now down here we are now going to look at arbitrary keyword arguments, whereby we do not know the number of keyword arguments that a client or a user might enter. So we are going to explain how to write a function to handle keyword arguments, arbitrary keyword arguments. So here we are going to write a get keyword arbitrary arguments. So I'm just trying to use shortcuts, but you can use any name. Then we use a double asterisk or 2 asterisks. Then you say you can say class, can be anything. Then here we're going to use our docstring and say using arbitrary keyword arguments. Then so we are going to say we are also going to use a for loop to get our data. For data in our class, we are going to print class dot get a data. So you can learn how to get a data from a dictionary. You're going to return nothing. When you look up here, we are using a key value pair. So that's basically a dictionary. So this is how we get our data from a dictionary. So we are going now to call our function. Let's say get keyword. Let me comment this. So if I run this function, I'm not going to get any data because I've not entered any data in our function. So if I say model equals to, let's put something there, then year of manufacturing, let's say 1989. If we try and run this, we're going to get Toyota 1989. So just to make it interesting, we can say here I'm going to write the key name. So our key name is data. And I put I put a comma, some space. If I run this, say model Toyota year manufacturing 1989. So basically this is how we use arbitrary keyword arguments. So next we're going to look at what we call pass. Pass is there to ensure that functions cannot be empty. So if a function is empty, we use the word pass so that it does not throw an error. So for example, you can say define test me, then use pass. Then you can just call test me, and if you're not using the function, just for testing purposes, when we run this function, we are not going to get any problems. But if we comment the word pass, if we run this function, you're going to get an error of indentation. So basically that's the importance of using the word pass in an empty function so that it does not throw an error. So next we are going to look at local and global variables in a function. So local variables are defined inside a function, while global variables are defined outside a function. So let's use an example of let's say this is a global variable. So let's say name equals to let's say a global name. Then we define a function, say get local name. Then inside the function we say name equals to local name. Then we print the name. Then outside the function, so here we just return. So here we'll print name. Then here we'll say get local name. So we are going to, is anything to comment? No. So I'm going to run this function. Say this is a global name, then this is a local name. So you see we are getting this value for the name. It's not bringing the one that is inside the function. Then for get local name, it's bringing this local name. inside a function. Alternatively, we can put an argument and say name. So here our name becomes let's say local name. So if we run this function, we still get the same results. So that's how global and local variables are used in Python functions. Next we are going to look at an anonymous function, or what we call a lambda function in Python. So an anonymous function is declared as, let's say it's a function x. It doesn't respect the rules of def keyword. So we just declare as, let's say, x equals to lambda. Then you start with the expression. The expression can be a. Then this is our return type of the data. The data can be a or a plus 1 if you want to return an integer. So our function is a lambda function which takes argument a, then it uses that argument to perform a specific function or purpose. So like for our case, this is declared a lambda, then this one is an expression. You can say an expression or arguments. Then now this is what the function does. This is now the execution part. So having those basics, we can write a simple example and say lambda. We can say sum of a, expression a, and argument a and b will be a plus b. Then we come and print our function sum, and we give it the two arguments. The first argument, let's say 1, another one can be 4. So let's just comment these two. So if we run this function, we get 5. So sum of 1 and 4 is 5. So here we said sum is our variable that holds this function, on this anonymous function lambda, which contains the arguments a and b and gives us a plus b. So when you print, the outcome becomes sum of 1 and 4, which is 5. So basically that's how a lambda function is defined. So the power of lambda function is seen when you use the lambda function inside another function. So for example, we are going to write a function that that's going to multiply or to add a certain number to the existing function. So you can say add other, add other number to this number n. So we are saying we are going to return lambda. So our lambda function will have a value, let's say a, then we say a plus n. So as we said, lambda function, this is now the argument, then this is the execution part. So if we call our function here and say now that we're returning a lambda function, we're going to initialize and say my function is equals to add the number, then we give it a value of, let's say, 10. This simplifies this one. So now our lambda function, which is initialized, which is returned here, which carries this value, we are going to say a lamp function will be equal to my function, then you give it a value of, let's say, 2. So if you print this lambda function, you're going to get 12. So let's just comment this. You're going to get 12. So 10 plus 2, we're going to get 12. So if we change this and say this is 5 or 8, it's going to be 18. So if you don't know maybe the number you are going to add to an existing number, or if you are going even to multiply with an existing number, anonymous functions come in handy. So next we are going to look at a recursive function. A recursive function is a function that calls itself. So you might have a function that repeats itself. So that function is called a recursive function. So we're going to demonstrate how to define a recursive function and how to implement in Python. So we are going to give an example of factorial. A factorial of n. So we are going to say if n equals to 1, we are going to return a 1, or print 1 if you want to. So here we use this equivalence operator, or assignment operator. Else if n is less than 1, we can return. If it's not applicable, you can do anything that you want to output. Then you can say else can return factorial you can say n times factorial of n minus 1. So what we have done here is we have done what we call recursion. So just explain when we are done. So if you write a factorial of let's say 5, so let's just print this, because this is what the function returns, so we just print it to get the value. So when you run, you should get 120. So just to explain what's happening here. So we are having an operation that keeps repeating itself, whereby the first value is being multiplied to the second, the result is being multiplied to the third, and so on and so on. So in step 1, we have 1, where n equals to 1, so we have 1. In step 2, we have 1 times 2, which gives us 2. In step 3, we have 2 we have 2 the result that we got there, 2 being multiplied to 3, then we get 6. In step 4, we are having our value here 6. Now we are multiplying with our value at step 4, which is 4. At step 5, in that order of incrementing the values, so we have 24 times our number 5. So as you notice, there is 1, there is 2, 3, 4, 5. So this process keeps iterating. So to simplify the process, we use what we call recursion. So that's the importance of recursion. So we are going to write one other function called binary search. Binary search is the fastest way to search through a list of elements. It's an algorithm that is normally asked mostly in interview questions. So it works with the principle of divide and conquer. So I'm going to demonstrate that. So let's say we have a list of elements or items. Let's call them from 1 to 9. Then we want to search for a value. Let's say a value of 6. So how do you go about it? So this algorithm works in such a manner that you have to find the middle part of the list. For our case, it's 5. Number 5, that's the middle part. So if we divide all this into 2, a middle element is 5. So if the value that we are searching for is 6, then we find that 6 is in the upper part of the list. If we are searching for a value 2, we find that 2 is in the lower part or the left part of the list. So I will proceed like that by dividing into 2 until we arrive at our position of that element. So I'm going to demonstrate that. Def b search. Then you say list of elements and say the value x that we are searching for. So first let's find the length of our list. So we find the length. Then our starting position will be position 0, and our last position will be the length of the list minus 1. That will be our last position. So we can also do this. We can check if the list that we have as elements, if list len is not none, or it's none, this means it does not have elements. Then we return our function to say no elements in list, right? And that will work for us. So what we are going to do here, we are going to say while the start is less or equal to the last index. So from our array here, we have our start is 1, then our last index is at value 9. So if it's our start is less or equal to our last index, then we start our execution here. So we start with the middle value will be our start, which is at 0, plus the difference between the last index and the first index, and divide by 2. This simply means you find the floor. If you get 4.5, it gives you 4. not 4.5, so we can use indices as they are. So that's our middle value. So we start checking now if our element in the middle, if our list middle is equal to the value x that we are searching for, then we return the position in the middle. Else, if the element in the middle is less than the value we are searching for. Remember here, if the element in the middle, for example, what we want to search for is here, it's 6, and the element in the middle is 5. So if 5 is less than 6, then we say our start now becomes a middle element plus 1. We are adding plus 1 because we can now start from the middle. We start from ahead. We add 1 to start from ahead. So that will be our start. Then we are going to say else, which means now you haven't made the conditions. You say our last now will be equal to our middle minus 1. So this is the vice versa of the upper one. So basically that's what we'll have. Then you can say also, so if we try and run this function, so here is our return. So if we try and run this function and say bsearch, let's say index is equals to bsearch, we have our items up there, then we have our value, then we print index. What are you going to get? We're going to get 5. So our value 6 is at position. It's at position 5, 1. So here 0, 1, 2. Let me start 0, 1, 2, 3, 4, 5. It's at index 6. So it means our array is working fine. So if we change to 1, what do we get? It's at index 0. If we change to, let's say 9, index 8, so here it is. So basically that's how easy this binary search works. Thank you for listening. If you like this tutorial, kindly subscribe. You can also like and comment so that we can continue teaching each other how easy programming is. Thank you.